Do you want to tell people about or do you want me to, about the thing?
Yeah, I'll pop up.
Come on up.
Hey, everybody. So this is going to affect the folks in the room a lot more than it's going to affect everybody online, unless, should we extend it to the people online?
You can. There's 2 online, I believe, right now.
I think at least one of them is actually in this room. Are both of them in this
Chris
room, the online people?
You're in. Yeah, Chris and Francisco.
Okay, I think Francisco's actually further out. So,
We have
yeah.
email.
Okay, so here's the thing. I have been a contributing author to the PowerShell conference book and an editor. We went live about 2 weeks ago, and I think we've published almost half of the chapters so far. We're doing kind of an agile publishing method here, where as the chapters are finished, we're publishing them. So pitch for the book is each chapter is written by a different person in the PowerShell community, MVPs, senior folks whose blogs you read, bunch of different topics. What we've done is we've each written a chapter here of a technical deep dive, the sort of thing that you would see at a PowerShell conference. And all of the proceeds for this book, all the royalties, go to benefit the scholarship to attend the PowerShell Summit's on-ramp program, which will get underrepresented folks into tech. It's specifically for people who are either changing careers or people who are trying to make a break into IT in the first place. Is kind of who it targets. So long story short, we're going to give away a copy tonight. So for those of you who are here and or on the stream, you got a shot at getting it. I think the minimum price for the book, if you want to go buy it for yourself like a good person, is $50, which I encourage you to do for obvious reasons. And I think that's it. Cool. Thank you so much.
Yeah, of course. Thanks for explaining all of that. As you'll see up there on the slide, if anybody's remote or anybody is super shy and doesn't want a mic in their face, this is a Google slide, so you can go to that URL and ask your questions there, and I should see it, hopefully, at least while I'm doing slides and not the demo portion. So there's really only about 10 slides in this, and the rest is going to be walking through how to do this in code. So the idea with this today is PowerShell 104, and this is our continued series, and tonight is going to be how to build a module using PSake, or PSake, or however else you want to call it. It's Sake, but still. Again, us 2 numbnuts kind of haphazardly run this, and Worldwide and Model are our sponsors. At least thus far. Obviously, we've been sitting here at Worldwide over and over, just because of the facility. It's kind of central, and they provide the food for us. All right, so agenda. Why would we want to do module building as opposed to just, writing something? Writing a module, as it is verbatim versus actually, quote unquote, not really going to call it compiling. It kind of is, kind of the same way you compile JavaScript this day and age. But basically, why we would want to do it, how we would actually, different ways to organize your code. So things we'll run into is the fact that we really need to look at using some type of source control. So this is when you've gotten to a maturity point where it's not just you, single guy, writing some scripts, although I still recommend you do this even if you're a single guy writing scripts. As you get more familiarized with source control repositories, versioning, there's a whole ton of benefits. So how do we do that? One, a big reason for this is so that you don't end up with one big script file that 15 people are trying to edit all at the same time and release different big pieces and parts of it. That gets really hard to manage. We're running into that here and there, even though we have different modules for technology, for automation stuff that we've written in Worldwide in PowerShell, it's still too much. Like, even though we have something for Exchange versus Active Directory, sometimes people are working on stuff in Exchange that isn't ready. Well, it's in there along with the stuff that is ready to go. How do you get this to go and that? It's just a mess. So code organization really helps when you get into teams of people. For a person, it's just great because of the history oh crap, I didn't mean to do that, I can go back, things like that, and just kind of keeps your code as a living document rather than compiled as just one document sitting somewhere and then, oh, well, that wasn't the latest version, it's over here in this directory, or oh crap, it's on that server and I forgot. And the last thing is we're going to take a look at actually building the module. Using Saki, we're going to do a very simple example. I pulled a couple of functions from, I think when we did like a calculator example or two back in like the 102 one, I pulled some of those in to do a very simple one. And then the other one is I took an example of a more complex build for a cryptology module that I wrote. And that will actually be, it does basically AES encryption of encoding and decoding of a string, for lack of better words, and uses a lot of the .NET modules for AES encryption for PowerShell. So we'll look at that, and that's available and be on public, and you can always look at those up in GitHub. So the why. So how do we utilize modules built with Saki? So again, why? Because the workflow gets way more complex when we talk about multiple people editing a file. It gets really hard trying to rapidly produce things or working on things together when it's just a single file. Worst case is how we originally did it. We didn't even put any of our code in source control. We just stuck it on the server where we needed it to run. And they're like, hey, what about that one script that did this one thing? And you're like, yeah, it's on the server in the C admin PowerShell scripts, Mike's crazy stuff folder. Great, it's not there. Oh, well, it's on this other, we have 8 Exchange servers. It's on one of them, go find it. And then the worst thing was, let's try to consolidate all of that and put it on a single server. Well, then you have to map that every time you log in, and nobody does. And so now you have like, well, it's over here on the share, but it's also still on the server. Ugh, it's pain. So a lot of this comes into, if you're going to have things that production is going to rely upon, like we have automation that runs. When a user needs something, that is a product that you have provided. It's not just some script that runs, right? So you want to be able to say, this functionality is this script, is this asset, right? PowerShell doesn't compile. It's just an assemble, module is just a whole bunch of functions. But you want to be able to say, this particular set of features is this particular version, let's call it that. Yes, we can version stuff. Yes, it's up to you. If you don't increment the version, you just overwrite your continual version 1.0, 1.0, 1.0 over and over. But a lot of these things come to play when you start working on a team or start thinking about providing business services via your scripts, right? So GitHub, let's just take as our example. We need some type of source control repository, SVN, I don't care. But we need something, it's going to be your single source of truth. What is in GitHub is the latest version of your code. And then along with that, and using Saki, we can actually do versioning. And a lot of this preps you not only to be able to do this for your own organization, but if you want to be any type of contributor, open source, put stuff on the PowerShell gallery, a lot of this is going to align building these things and getting it ready for it to go onto the gallery. So it's dual purpose, right? It's getting your organization to understand why this is beneficial, but then also for you, you have the personal benefit of, hey, if I want to go do some stuff with open source or just contribute to the community, I can. Mike.
Yeah, one of the things to point out too is that this also kind of sets you up for like continuous integration, continuous testing type stuff, which allows you to make sure that the stuff that you're running in prod is safer, right, and is more usable, and you can deploy those fixes and patches to it a lot faster.
Yeah, definitely. So one of the things I didn't very purposefully, because this could be a all-day presentation probably, is start to get into testing and all of these other things. Now, my crypto, you're going to see it there because I have it. I have tests, I have script analyzer, I have a bunch of these things in that as an example of where you can go with it. But the basic one at least is there to just get you started. Because then once you're like, All right, I got this build thing done. What's next? Well, some tests. And we'll see that in the crypto because I want to make sure if I make a change that the thing I encrypt decrypts correctly. It's kind of important. So those are where tests can come in, is you kind of mock up scenarios, right, to where you can actually test your code. You don't have to have all the other framework. You're just testing the individual functions. So next thing, that's kind of the why. Next thing is code organization. Why is this important? Well, so we have a couple of choices, and I'm sure there's a lot of gray between what I call simple and advanced and what Mike calls simple, and 15 levels and then advanced, and then, oh my God, I'm crazy down here. Because if you look at certain things, and we'll take Mr. Lombardi's documentarian as an example, there's a lot of advanced building going on to the point where he's building his stuff so that he can provide a scaffolding for you to build your stuff. And I haven't even gotten, my advanced doesn't even include the documentation stuff that Mike has. So that's down here. It has some. I will show you that. My advanced, the crypto one, when we get to that, does have that. But as far as code organization, again, I'm not kind of getting into the test stuff and the other things. So we'll see what I mean when I get there. So we're going to open up this guy, and give me just a sec while I duplicate my displays and you can see my screen. Did that flip over on the presentation? It probably takes a second on the webcast. It should. Actually, I can check. Yeah, okay. So out here in this repo, I linked to it in my presentation repo in my personal GitHub, PowerShell 104. And a couple of things here we'll go over is the organization of code. I'm gonna blow this up so that people can actually read it. Super big. There we go, one more. So there's a couple of prereqs before we even get talking, and we'll get into those when we start doing the build. You can see some of it is, hey, some type of source control, Git, hey, some type of building process. We're gonna be using Saki. Again, there's a couple things we actually need to install on our system is git install to install Git, if you want to use Git. And then as well, PoshGit, it does actually still work, believe it or not. I don't know if they updated it, but it is working. Again, it kind of went petered out, but it does work. So it's an optional thing. It just, I'll show you what that does, what it looks like. And then install module name Saki, super simple. That just pulls that off the gallery, PowerShell gallery, that command. So let's talk about the organization of a source directory, and we'll just look at a very basic example here. So there are a couple of decisions. Basically, this is pretty much the simplest way I think you can set up a Saki build. Probably even simpler, but at least to get the idea of why, you could probably just make a whole big single module and use Saki, but I don't really know what the point is here. What we're doing is build, and I forgot a file, really it should be Saki as well, but you can include it in one, doesn't really matter. The idea is, when I talked about having a team of people, and if we just had these two, the module, PSD and PSM one, or worst case, just the PSM one, because nobody writes a definition for their module, and you check that into Git. Again, 15 people are going to be editing this single file. Not super great. Hey, I'm done with my function. I need it in prod because this, oh, but I haven't finished mine, so it's going to break. It won't even load your module. Okay, that's like basic Git. Hopefully people are using feature branches and everything, but I'm talking way down the road in Git. If you've never heard of source control or used it that much, people probably aren't going to be feature branching, just getting started with it. I don't like to say that, but it does happen. So, and continues to happen. So This splits each and every function that you would write into a PS1 file. So if you had 15 functions in that module, you'd have 15 files inside that functions folder. They are not, you know how you can make a file be a function, where the name of the file is a function? That isn't how that's written. That is written as a function, get something inside of that file. It's just a way to store that in an individual component. So then what happens is we have our definition that explains what the heck this module does. We'll go through that when we look at the simple example in code. And then this PSM one is a very interesting thing. This is really only here so you can debug. You can load that PSM one, but the code isn't in that file. That file, and I'll show you, is boilerplate. It just loads all of these functions into memory as though it was loaded from a module. That's just there as boilerplate. Build is what's actually going to be there to kick off our build. So that's a very basic layout of how we would organize our code. Nothing yet really has to do anything with Saki, but it does in the fact that this build is going to actually make all of these appear in a final compiled module. You guys have any questions why this would be needed? Because the next one's going to look even worse. So, does this make sense why we would do this? Yeah, thanks, Mike. All right, so this next example, as you can see, this advanced is going to include testing, documents, it's a full gallery style, and potentially working temp scripts. So this is obviously more. Yeah, I can't fit it all, so I'm going to go one smaller. There we go. Okay, so when I compile something, quote unquote, I'm just going to call it, kind of compiling it. We'll just call it that, even though right now just realize we're not actually compiling it into a binary file. You're going to have some type of output directory where we actually store the compiled code. If we're using testing, and we've talked about this in the past, Pester, well, we could have a whole talk on Pester. Mike can give that because he's done it before instead of me. Testing results will end up in there, and that's part of your build to just say, hey, go to this folder. I don't want you to put it somewhere else. I just want all of those there. And it's just an XML output of what happened during your tests. To go along with that, there's a test folder where all of your tests can exist. They can exist alongside your functions too. It's up to you. I like them down there in a tests folder just because segregates them away. It's 50-50, doesn't matter. The only requirement is notice with tests, and we can get more into that with a pester talk, but they have to be called your thing dot test, it's plural. So if I wanted to test next to this get some stuff, it'd be get dash some stuff dot tests dot ps1. That's how Saki knows to ignore that and does not include that as an actual file when it goes to compile this. In this example, I have a public and private folder underneath functions. That is to say, hopefully with a module, you guys remember, we can expose functions and hide other functions. So that's what those are for, to help segregate those. Again, completely optional, but great if you're actually utilizing it. Working is just something I've used to great effect, where I just have to test some stuff, component stuff, like, I'm just testing my module. I just throw some stuff in there and I have Saki ignore that directory, just so it's at least there in my code, as I'm doing stuff. Again, you'll see outside we have those module PSD1, PSM1, again, those are that boilerplate. The PSM one is. PSD1 is actually describing what we're doing. That's what that's there. And then down below, you'll see we have some additional documentation items along with our build, and hey, a new .getIgnored. So that .getIgnored, because we have all of these outputs like the output, the test results, potentially the docs, potentially, unless they're packaged with it, which probably not. Those are all basically in there so that it ignores checking those into, well, the docs it wouldn't, but those top two folders, it would ignore putting those in to source control in the first place, because you don't want to source control your compiled assets, right? So
yeah, you basically never want to source control output. Like if you can programmatically generate it, you just want to do that on the fly. There's no reason to check it in.
Yep.
You always want to check in whatever is going to be the input. The output doesn't matter, right? Because you can just regenerate it at any point.
Mm-hmm. So you can pull up this version of the code, this revision, and always regenerate the test and the output at any given time. So version 1 always has this output when I compile it, and always has this test when I compile it. Version 2 always has this output and this test result when I compile it. So that's why those are never checked in. And that's all that a getIgnore does. You just put like /_output_star, and it ignores all the stuff in it. That's, again, just for Git, but if you're familiar, obviously you know what a getIgnore is. The rest of these are really kind of to align with the PowerShell gallery and the way they do and require certain documentation pieces in your module. So a changelog, which, gosh, I think it's just, is it keep changelog?
Changelog.com.
Keep it changelog. And literally in my changelogs, I have a link to that, so I remember what the hell the website is, because I can never remember it. Kind of like WTF Git, yeah.
Oh shit Git, you mean?
Oh shit Git, that's it.
Yeah.
Yeah, if you like screw stuff up in Git, you just go to there, it helps you out. Contribution, this is kind of a boilerplate thing, like a GitHub, how to contribute to a GitHub project. If you use something like SVN or GitLab or anything else that's GitHub, obviously that's just instructions of how to contribute. The license and a README. README is going to show up in GitHub of, hey, what this thing is. So that's kind of to give you the idea of full on versus simple. So my two examples are going to follow this pretty much, these two types of examples. Again, some of this is subjective. If you have and use classes, you might have a classes folder and you would include that. You know, so again, it depends on what you're using and what you want. You could end up not ever having a public, private, and just have functions. Mike? No? Okay. So again, a lot of this is up to you. This is just a structure that I've seen worked a lot. A lot of examples are at least have a source, a functions, you know, the basic stuff. Some of this is a little bit of flavor thrown in, but a lot of it is very close to what the gallery is going to want as far as the documentation, how to compile this. But this gives you the ability, either of them, to really get a handle on being able to deploy different things, different pieces at a time. So, all right, so that's code organization. So let's see if I can get this to work, getting back to our, this guy. Do I? Oh, do it in one of the, link for the, oh, the Google slide thing. Let's see. Oh wait, that's not it. I'm trying to get back to my webcast. Yeah, I know. Whoa. Wait, it's coming. There it is. Webcast. There it is. Audio works. So just FYI, the link isn't working for others. Is the GitHub Ken Maglio presentations that link? Francisco? The GitHub link? Maybe he'll submit another question. Let's see. So it should just be in here. Yeah, this shouldn't be private. Yeah, this should be. It is HTTPS. Oh, the link to the video? Yeah. Yeah, it's got like a good 30 seconds. So that's the presentation link. The webcast link, like if other people want to join, should be this guy. They do have to like sign in, quote unquote, but that whole thing should be the VBrick video link doesn't work for others. That's weird. That should. I know you'll have to sign in or quote unquote sign in or create a just put your email address in there. I know that, but it might be blocked, but that's external. It shouldn't be. Really? Okay, hold on. Attendees can see where is the. Of course, the link doesn't want to be super helpful. So that is the link. Event 47, right? 47 ends in CD. 47 ends in CD. It should be wide open. It might be a VBrick outage of some sort that we're already in and good. Unfortunately, that's super horrible. Oh God. The only thing I say is at least it's recording, so at least we'll have this afterwards to give to people. So this will be recorded as a live presentation as well. So if that helps, sorry. Yeah, the live stream is well, and it's always flaky at best. Okay. Okay. Yeah. Let me know if something weird, or let me know if there's stuff in the chat. Beyond that. So the next thing is going to be building a module. So we're going to go through next thing here. I'm going to open up Visual Studio Code. We're going to look through some boilerplate stuff, a simple example, and then some advanced examples. When we get to advanced, you're going to see, because again, I'm reusing something that I've already written. There's going to be tests. There's going to be some other things in there. Don't get super confused with that. Just realize this is where it can go. Okay. So let me try to flip over, and I will obviously increase this. Boom, boom. And we'll get rid of this README. And we'll go into simple. Okay, so we're going to close that. So is that big enough for people to see? Okay. So I'm going to go one more just because I'm going to be super annoying. Okay. So right now, and ignore the fact that I called it bin. I know that's stupid, but that's me from old .NET days, actually compiling like assembly. My output folder is always just called bin because whatever. So it's not really binary. Okay, so this is again the idea of a simple setup. If we look at just what's in simple, bin is output for me. We've got my source, we've got a function or two here, invoke add, invoke multiply. We've got my module name called simple, a PSD1 and a PSM1. So let's take a quick look at PSD1. So a PSD right now for this, oh my God, get out of the way, PowerShell. This is literally taken from like how to write a definition, module definition, like from Microsoft's like MSDN sites, right? Or TechNet or whatever documentation. So this is right out of it. If you're wondering how to get a new GUID, there's a command in PowerShell called new-GUID, and it spits out a GUID. So this is just some basic metadata. The biggest thing in this file is the name and the module version. Those are some really important things. And then what version of PowerShell do you want to require? So I could set this to, whatever version. And then down below, all of this stuff I pretty much ignore. If you get into like writing .NET assemblies integrated with your, okay, fine, let's not worry about that. Down here, there's things like doing dependencies. Again, this is kind of advanced stuff, but this is all boilerplate. This is just straight up what a module definition looks like. The other big thing down here is these. Functions to export is kind of probably one of the biggest things here. Maybe variables to export, depends on if you understand and want to utilize those. Functions to export. Right now you can see it's everything. It will export every single function. Now, why do I care about this? Well, you know that really cool thing, like if you go install import module Active Directory, right? So let me, and I apologize for this being super small because I wasn't ready. We're gonna properties, font, 24, sure. So act, oh, I'm in core. That won't work in core. I know. I'm waiting for that yet to be fulfilled. Okay. We can see. Yes? Good enough? Okay. Import module Active Directory. Okay, there we go. Active Directory loaded. Now, here's the fun part. Now that's loaded, I have things like get AD user, right? Yay, there's me. Okay, great. So now you know what my account is. Woohoo! Not that anything secret is here, but whatever. So that's how you would normally do it, right? You'd import the module, you have access to the functions. Okay, we're gonna close. I hope this saves. Yeah, it did. Okay. However, because my module, or Active Directory module, is located in a known PowerShell directory that PowerShell is aware of, and because in the PSD file, their definition, they actually specified every single function that they're going to export, PowerShell can do this really cool thing. Now notice, I don't have why is that loaded? Thank you. Thank you. Ugh. Stop it. Okay, so in this case, module is loaded, doesn't return anything. If I loaded it, I would show you that it actually does. Just to show you what it would look like. It would actually return something if it was loaded. And notice all of these exported commands are here. Well, that's because they defined it as such, okay, in their definition language. Well, the cool thing is, because that's sitting there, one, what I did before when I said, where is it? Get command AD, the fact that it pulled all these back without me having to load the module knows because that module and its definition are sitting in a known PowerShell location, one of the PowerShell path locations, And they've listed every single one of these as an exported item, either function or command. I haven't loaded this yet. I haven't loaded the actual module in this window yet. Remember, so it's not here. But if I say get AD user, this will work because it knows where it is. It knows exactly what module I'm talking about and will instantaneously load the Active Directory module for me and work. So that's why you care about that particular feature of a definition. If you distribute and put your module in the PS, in the, was it PS path? Module path, thank you. If you put it in one of those directories, it will know the functions that you have and are available, and it automatically loads your module.
It's also necessary if you are going to use private functions at all. So if you have functions that do helpers or that like reach out to an API under the hood or whatever, if you just have the star there, those are all callable as well. If you just want to expose a set of like vetted known commands that are going to be the type that you expect users to interact with, you have to use that.
Yep. And I have a example of this in my crypto stuff where I have a private function that I don't want anybody else to be able to call just because whatever. But I have what I've exposed as my helper functions, right? The easy to use functions. I don't want them to have to know, hey, you need to provide a byte string that's no, just here, provide me these nice, easy things and it'll work. So I'll show you a reason of what that can look like when we get to the advanced. But this is important. This is defined. If you go look up Microsoft's documentation on this, it will tell you about these things. I just want to make you guys aware of that particular one. You really won't use commandlets to export. I think that's if it's a .NET module that you're pulling commands out of, which a lot of the Microsoft stuff, like Active Directory, is actually a DLL. Variables to export is kind of weird. It'll expose a variable from the module outside of the module on import. So,
right. Important thing to note there is that that variable only exists in the scope the module is imported to. So one of the things you'll see people do occasionally when they want to get at those variables is they'll import the module to the global scope, which please don't do that. Like, there's no reason. It'll be okay. And then another reason to do that is if you're going to have like helper variables that will persist and kind of make things a little bit easier on the user. That's a good place to stick them. You don't see it used very much though.
No. It's there. Again, it's one of those things be aware of. But the biggest one is functions to export. If you're going to want to hide a function, this is where you wouldn't export it. So it's obfuscation by, or security by obfuscation.
One of the advantages of the aliases to export. So like when you use get child item, like GCI, those types of aliases, you set those for each of your functions and then export those. So there's a faster way to use it at the command line, so you're not typing out get dash 37 words that follow the dash.
But isn't that why you have tab complete? Anyway.
That's why I have tab complete.
Right. So there's some other stuff down here for the gallery, private data, PS license project, blah, blah, blah. And help info, like, hey, where do I go to actually get help with this thing? So that's what a very boilerplate PSD1 is. That, again, that's documented by Microsoft, but realize the name of the module, root module, version, having a unique GUID, and then functions to export. Those are kind of the four big ones out of this whole thing that you really need to worry about. Okay. So now let's look at, yeah, sure. Let's look at this. PSM1. Okay, and I'll close this to make room. So this is boilerplate. Remember I told you this has nothing, no code in it, no real code that you're actually doing. Why? Because what it's doing is it's looking in my current directory, script root path, right? PS script root, which is whenever I execute a script, it's in that path, / functions. Okay, so I'm going to be executing this inside my source because this is where this simple.psm1 file is. So it's going to look in functions, get all the functions, and basically load them all into my current scope, right? It's going to load the dot file full name, actually loads them into current memory, as though I had loaded this into via if a using it as an actual module, if I had imported the module. The bottom line, note this little text I've added here, which I'll put this on the next line so you can see. This last line of the file will be copied by Saki build task. So if you're only going to export certain functions, this is where you would have them. So this is, Saki does this. This is, if you had a hidden function inside of your code that's not a, it's hard to say this, because you're doing the export, this actually prevents it, right? The definition, the PSD one tells PowerShell, the system itself, what you're going to export. This actually prevents it when you load your module from loading those private functions into memory. They're there, they're just not exported into the scope, so that any other public functions you put out there can still utilize your internal private helper functions. They're just not published into the commands available for a user to execute. This is what actually does it. So if you have functions that are going to be private and you come up with a naming standard, like, I don't know, whatever it is, dash PRI for private, don't ask me. I'm just coming up with something horrible, but just an example, you can say, I'm going to export everything. Well, that's even worse. Whatever. Well, in this case, magdev, whatever, doesn't matter. So if I put my company name, git dash my company name or something, which again isn't great, but I could say only export things that follow this pattern. It's one way, not great, but you could also just list them, okay, to export them, probably the best way, but that is what actually does it. Does that make sense? That's actually the code that does it. That line is copied into Saki at the very end of your actual PSM one. So basically, it's going to take Saki, when we get to the build, this thing that we use for debugging and like loading our module to test, it's going to replace this with the actual code itself. But this last line is going to stick. So that's why that's important to have. Plus, as you test, it's going to allow you to test the same way that your module is going to be built. So only the functions you want to be exposed, even when you're testing, are going to be exposed. So that is our no, I don't want to save. Okay. Really? No, I didn't want to save. Thank you. All right, so a couple of quick things. Let's look at a quick function. I know this is super huge. Notice this is not a file as a function. This is not, I just named the file, Invoke Add, and I just started writing code. This is actually putting your function itself in code. So this is because of the way Saki is going to build this. It will actually basically take the guts of this file and put it in your actual module. So this is just a simple invoke add. I kind of documented it. Output type is going to be an integer. I accept two different integers and I add them together. Again, just showing you can use full-on functions here. There's no restrictions. That's a really weird setup on parameters. I know this was pulled from one of our examples because Mike's looking at me like, what the hell is that? Trust me, I know. And then multiply, I changed one stupid sign just to show you I had two functions here. Yes?
Mike was actually thinking that you were a C# developer in a past life.
Why?
Because you're using return even though it doesn't do what you want it to do. We could talk about that later.
Okay. I use return like that a lot. Return? It takes a sec.
You can test this. Go ahead and put like a bunch of different text before that, like in the output stream, and then do return $C. You'll still get all that other stuff. Like you're used to it just returning whatever's on the line with the return, but in PowerShell, return's just going to end the scope, and you're just going to come back, but all the output's still going to come with it, including $C. So if you have yeah. So, but it's not like it's not the only piece of information that goes to the output.
Correct. Right. I just like saying, so yes, I'm very careful to make sure that I don't output anything while I'm inside of my function, other than maybe write verbose. But yeah, if I do a write host, that's going to the screen, right? Or if I do anything like that, or just put C and it's going to output it.
Right. Anything that leaks into the output stream will still come back, even if you use return.
I do that, again, probably because I'm a .NET, but I've also seen a bajillion other people do this, probably because they're developers.
All have it, yeah.
The only, I don't like just outputting it in the middle of it because it doesn't look like it ends. But that's just me. Shame. So, hey, I will tell you, when you go to classes, you do have to use output, though. So let's take a look. The next thing is let's take a look at a file. Now, again, Saki is documented to the nth degree. This is going to be a combination of two things. There's a module that Mr. Lombardi told me about called build helpers that does help a lot of things when you do this, like environment, like this project path, and it takes into account when you fire this off. That's why I have a build script and a Saki script. My Saki script is pretty much some properties, but then tasks. Okay, and that's how a Saki file is made up. So if I want to do a different build task, I'm editing Saki. If I want to set up the environment prior to me running Saki, I do it in build. When I want to compile my stuff, I call build. So that gives me the ability to do different things, and I'll show you build in a second. Did you have a thing, Mikey?
I was just going to say that it's useful to separate the concerns. So Saki is concerned with the organization of the tasks. Build is concerned with the build environment and which tasks to run, because it's gonna call Saki afterwards.
Yep. The last line in build is, well, last effective line in build is to call Saki with a task or a default task. So some of these properties are coming between build helpers, which kind of bridges the gap between my build file and my Saki. And what it ends up to be is a couple of different things. Project root, directory I'm in, the name of the module, okay, I'm getting that from build because that's where I'm actually working with. And then things like the version, it gets that out of the actual module and gets the version from the definition language that's sitting there in my PSD one. Build folder, version folder, I'm just building those because they make sense, because look, bin, if I had output, it'd be output instead of bin, so I can set that. And then there's a version folder. So a lot of these two things are helping me set up the output so that it can be mimicking more of a PowerShell, the PowerShell gallery style of how a module is assembled, or how you would zip that up or package that up into a NuGet package and deployed. This is also usually, when we see the output of this, how things are laid down inside your actual PS module root folders. You'll see it that way as well. So you can actually have a folder called something. We'll have a folder called simple, and underneath that a version, and underneath that the actual module. Well, if I point and say install module simple, and it's in a known path, it'll pick up the latest version. If there's 1, 2, 3 in that folder, it'll pick up the latest. I can also tell it, no, I want you to load version 2 as opposed to version 3. And PowerShell knows how to do that based upon this folder structure that we're laying out. Again, a lot of this is boilerplate. You can, once you've done it once, you can copy, paste it, because as you see, none of this is module specific. It all comes over automatically using build helpers. So a lot of what you do in Saki is reusable, which is great. This, if you do a very basic one, in other than bin, that's the only thing that I have hard coded. This whole thing is reusable. You guys could take this out of my repo and just use it as a Saki file. Couple of things that I do, I'm going to hide this. So when we call Saki, Saki is responsible for creating the end source. I'm going to create my build folder if it doesn't exist for the first time, okay? And that is going to be the name, right, of my, there it is, the name of my particular where I'm at, bin, and the module name. So it's going to be bin simple. If there's stuff in it right now, go clear out. Recurse, clear out that bin folder, right? Then I'm going to create the version folder that I'm working on, 1.0.0 in this case, or 1.0.1, whatever. I'm then going to copy my manifest, my PSD1 file, because that comes over verbatim. That is already sitting there in my compiled form. The next thing I'm going to create is a new item, and it's going to be my new PSM1 in that version. And then the next line, 3536, that's going to take and recurse through all of my functions that are sitting there in that source directory, load them, and basically get the content and output them out to that particular function variable. That gets loaded here. So add content, everything that's in this. And then basically the last thing is pull out of that PSM the last line, which is that export module member, pull that out and add it to the end. So that's what that does, all of that so far. Next thing is verifying the output. Yes, question.
So if the module file, the PS or the definition file has the version number in it, does this automatically increment that version number, or
No.
do you have to update that manually?
Yes, you have to manually update the version number upon build, because you could be getting to a point where you're iterating over a development and you're not going to want to rev each every time you're debugging this. Only when you're ready to commit it, you're like, I built it. Yep, 2 builds, perfect, go. So the first thing that I do is I come in, if it's a new whatever, I'll ink something. I know this is a minor revision. Shit, I know this is a really small build revision, right? There's a small bug. It depends on how you want to do, how you interpret your semantic number versioning. But it's really up to you when to do that, because every time you build would probably get a lot. I could see where maybe that build number, the very last one, could be incremented, but you'd have to do something where when you run that other file, the build file, would actually have to go in to the PSD one, look at that file, look at that thing, increment the last digit of the semantic version, and then save the file before it passed to Saki. You could programmatically do it. This just doesn't. If that's the way, every time you guys run a build locally. Now, the idea is you run builds 15 times locally for the new version. Once you have it working, you check it in, then your CI/CD pipeline actually builds that version and stores it somewhere in Artifactory, ProGit, something, a file share. So that's what this does up to this last piece here, this 43. This piece, I don't think I even modified this at all. I literally think I stole this from Lombardi, who probably stole it from somebody else, because this is like Saki's documented, hey, throw this in here. And it literally just tests that the module you exported is actually has the exported functions and alias and variables that you defined in your definition. So what you told it to do is actually what it did.
Yeah, I'm pretty sure I stole this from Brandon Olin back
Yeah.
before he took over Saki.
So there you go.
Probably why it's there.
There you go. So in a roundabout way from Saki at some point. And then it just outputs all this stuff for you, right? Your name, description, good, all this good stuff that we told you about is important on the screen. And that's it. So really, it's all about just compiling this PSM1. That's the heavy lifting that this does. The last part is just verification that we stole from people, because that's what you do on the internet, right? So let's look at the build file. Okay, so this is super, okay. I did this when I had to do something different, or I had a module that didn't work in core when I was compiling that did work in, what'd Windows PowerShell versus PowerShell core. And those were different, but when I took it down to the simple example, they were the same, but I said, I'll leave it so you guys can see. But if for whatever reason, that could really be super consolidated down to just modules. So then this just allows me to pull each module. I think I grabbed this from Mike. Again, whatever. All this is doing is loading those as part of my build, okay? It's really not hard code. You could just put at the very top and super simplify this and say, look, import module Saki, import module build helpers. That's all this does. That's it, all of this code. 23 lines for 24 lines, 25 lines of it. You could have simplified this with 2 lines, but I wanted to make it dynamic in case I wanted to play with things. So that's all that does. Okay, this is really what my script does. That's it. So it pushes the location of my current running script to push location. I believe, correct me if I'm wrong, Mike, that build helpers uses that to be able to detect certain things of project working directory. So if you push a location, push location, pop location acts as literally a stack. Whatever you push in, pop, you gum, right? Old push pop type stuff. Yay. So that does that. Child item, now this is the build helpers, right? So get child item, path environment, BH star. That is all the build helpers. And it clears out the last run of environment variables. So if you, for whatever reason, go to this directory, run a build, switch to a different repo in the same session and do a build, this stuff doesn't commingle with this stuff. That's all it's doing. It's clearing those environment variables, because that's what build helpers does. It throws a bunch of variables in the environment so that it can communicate between your build and Saki. So now that you have that location pushed, we've cleaned out all the old crap. Set build environment actually sets the build helpers stuff up for you so that all of that stuff is consumable in Saki from this current location. And then the last thing is we just execute Saki. So we say build file is Saki, which is in my current directory. Properties, PS bound parameters. That is whatever I've passed to my build file gets passed to Saki if needed. No logo and task list build. So if I wanted to specify something other than default, this is where I can do it. If I set up different tasks, build, deploy, test, I can specify what I want it to, what I want Saki to do. Right now, we only have one thing, build. That's all this does. So I'll do this in core. Who cares? Because core works. Now I have to go over to it. Nope. Example. Oh. That's a path. Okay, so I'm sitting here in my root directory where my simple module source is located, right? This is the root directory. My source folder is there. I have my functions inside of that. My output folder is bin. I've got my git ignore, my build, and Saki. This would sit in a repo in GitHub, okay? This is literally the repo I would suck out. Now in mine, I have whole examples, but this would be your repo. So in order to build this, I'm gonna run build. And you're gonna see what's done. So that's it. First couple lines is from build. I'm importing Saki, build helpers, already loaded, already loaded. Hey, I loaded all my modules, complete. Again, all of that could be 2 lines of code if you wanted. Retrieving build variables, executing Saki build. That was the last couple lines. Once it says executing Saki build, I'm now in the Saki file. I know that's stupid hard to read, and I hate that it's dark blue text, so let's see if this helps. Oh, that's even worse. Oh, PowerShell, how I love thee. Oh, I know, shush, I'm trying. Oh God, that's worse. Where's the dark? What? But can I just use white? What is what? I have no idea. Connie? Okay. Yes. I have no idea what this is. Fair warning, this is a Mike Lombardi thing. Well, I know, that's because I've done this. I've done this horrible thing to make it somewhat, see, that's what it should be. Okay, now what? This? Yes, I like modify. Wait, this is PowerShell? Sure about that? I am using Control Shift Plus. The other control? I saw this here. Oh, that's opacity. Okay. The hamburger or the, okay. Size and position. Can't I just do this? Oh, all right, fine. 24 is what I want. There we go. Sure. Save. Is that good enough? Can enough people see? So let's see if we, oh my God, here we go. I did it, a bunch of them. Because I can't type now that people are watching. Oops. There, now it's 1. I'll have to get used to this. I have never used. Oh, that's all of the. Nice. Yeah, that my build. It doesn't do. Gosh damn it. So what, that? I hate you. All right. I know. Thanks, Mike. So, you sure? Hey, look, but it looks better this way. You can see it. God damn. This is good. I think people can read this. This is yeah, I think. Oh my God, no. All right. So, back to the whole Saki explanation here. So once it starts Saki, it does the build. We saw in my code, it said, if this already exists, clear out the existing build folder. So it did. It cleared out simple because that's where my module is going to be. So it cleared that out. Then it created the version folder, which in the output we can see is going to be 1.0.0. Copying the module manifest, which was the definition, PSD1. Creating a compiling module file, PSM1 file. So the module is now built, and it verified that if it loaded it, this is actually the stuff that was outputted. Notice in this, even though I specified star, the module knows that those are the only functions that existed in the module, therefore those are the ones that were exported. So therefore they are there. Build succeeded, gives me this nice little report here at the bottom of how long each step took. So that is a very basic build. That is kind of the first intro to Saki. What I want to do is take a 5-minute break because I need to clean up dinner for the cleaning crew real quick here. And then I'm going to go over the complex crypto one. If there's any questions that to be had, we'll ask them, but we'll answer them back here. So we're going to just take a quick 5-minute break here, people on the presentation, and then I'll edit this 5-minute break out of the ending video. So, all right, I'm going to unmute me, or not mute, I'm going to unmic me. That way you don't hear random crap from the other room. All right, we'll be back in 5. YouTube channel, we were using that a lot when we rotated around, and Mike would just run like Hangouts or whatever it was. Not Hangouts. Was it Hangouts, Mike? Yeah, and a webcam. So once the videos are published to VBrick, there you can we can download them as MP4s and upload them to our YouTube channel. Yep. Because I have them all the ones we've done here. I have them all recorded when we started recording these back. I think the whole PowerShell series, the 10 whatevers, they're all there on VBrick. I just need to. We can just grab the MP4s and push them up to. That would be nice. I don't want to script against VBrick though. Although it would be just a straight download, but you have to log in, and that's a. I think guest login. Maybe not. I forget. Anyways, Mr. Lombardi's. Okay, so all right, I'm back to. I'm online. Yes. Okay, we should be good. So that was a basic, very simple example of how to take Saki and only really utilize it to help compile and build a module. So again, the reasons why this is helpful is if you have a team of people, you're running into 5 different people editing the same things or working on the same things. You don't have a single source of truth. Your scripts are out in your environment in random places, or worst case, they're on your local laptop and you drop your laptop and you lose everything. Whoops. That's never happened. So the good thing is GitHub or source control or something. Doesn't have to be GitHub, but SVN, GitHub are pretty much the 2 things. GitLab, still Git. So this is the basic layout. Now we're going to go into the next one here in my simple. Again, this is still the same stuff, just so you guys see. This is out here in presentations, 104 examples, and this is crypto. So let's take a look at it here. This has the README, which has some other stuff. So this is the README that I have in this source repo. This would be a repo usually all in and of itself, and this would be the regular repo. You've got a link to the changelog, a link to how to contribute, a link to the license. Just so you can see, the changelog looks very much like this. Look, based on keep a changelog. How do you keep a changelog? You do it like this. So as you go through things, you can see how things are added. Go to the site. It helps you basically build something like this in Markdown. Contribute. This was snagged from random, like, public GitHub, I think, even has this. So it's just a bunch of blah, 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 blah. See, links to GitHub. And then license is just whatever basic license you want to file under MIT, whatever Apache, blah, blah, blah. So those are all there. Those are just links to those. But as you can see, we now have source. We have tests as 2 folders. Again, as you can imagine, what's going to be in source? Functions. And then we have build and Saki. This Saki is a bit more complex. The build is pretty much the same. My build really doesn't change that much between modules that I have, because they're usually set up in very much the same way. Saki, for the most part, same thing. If I'm doing the same types of tasks, I can just reuse them. That's the whole point of this, is very reusable, modular type things. So those are the only things that are there. However, when we come here and look at crypto, I'm going to close this. You're going to notice I have bin, test results, zip, git ignore. I have a whole bunch of other files in here, but that's because these are in my git ignore. So that's what a git ignore looks like. Ignore bin, zip, test results. So it never checks those into GitHub, because these are just output folders. These are rebuildable no matter what. So let's take a look at source. And here is my module. I called it magdev crypto, PSD, PSM, release notes. So PSD one, and I'll close this, looks oddly familiar, just like our other one. However, I have 3 functions that I export. Convert from, convert to encrypted string, and get non-zero bytes. That's about it. That's the only real difference between this and the simple. That's it. And this is module version 101. No real different. If we look at my functions without going into it, notice I am utilizing private and public. So what's changed is here in my module file that's for debugging, I go here at the top and I grab my private functions and then I grab my public functions. That's it. So, and the reason I did this is just because I can get the output, so I can actually see importing private functions, importing public. So if I have a problem loading a function file, like I didn't code the function directly, I can see where, what folder, that kind of stuff. So that's it. Notice that's real no different than anything else than the simple. The only difference here is I do have 4 functions, but this private function, get AES crypto manager, is not exported, meaning it does not end up in my scope when I import this module. But these other 2 functions, this is a helper function, but the convert from uses get AES and crypto manager, and the convert to uses AES crypto manager. So I'm not too worried about showing you guys or like getting into the details of what these actually do. Realize they actually encrypt and decrypt strings using AES encryption. So there's a passphrase, a salt, and an IV hash that are needed. Those are all utilized plus your string. So just for example, here are those things that I pass. Plus I have, in this case, parameter set name, AES versus params. If I pass in, for ease of use, a hash table that happens to have passphrase, salt hash, and IV hash in it, it will use that first parameter set and it will pull this out. And my crypto manager can take a hash or the individual pieces themselves. So I did that. Yes, I'm loading system security, which is a .NET assembly to do this. And that's about, there's a whole bunch of fun stuff down here, which sucks to figure out, but it worked. The more fun one was this one, because yes, have fun with my comment. Using this silly loop format to loop 1 character at a time so we never store the entire password naked in memory. Okay, I'm not saying this is the most secure code in the world. I'm not. But the entire point is that the stuff that's encrypted sitting on the drive, the secrets aren't stored with it. So if you access a server with a password that's been encrypted with this on a server for whatever reason in a file, the keys are stored elsewhere. We use Jenkins for that. Like if you execute something, I always pass in the AES hash of these variables from Jenkins and then pass that into my function, and my function decrypts and goes. So the keys to the kingdom are never with the secret. It's the whole point of encryption for the most part. Script analyzer, which is utilized in this, which is checking your code for syntax, linting, problems, bitched hard time at me because converting the stuff out of my my security crypto stream variable directly into a secure string, the only way to do that in a one-liner was to do it as plain text, and that's bad. So what I'm doing now is character byte by byte. I'm now taking that information out and converting that character by character, the password character by character. It still has to come out plain text somewhere. There is no way to convert from that I found to convert, and I searched and searched, security crypto stream, because that is a decrypted string at that point, a decrypted stream at that point. There was no way to convert from that out to a secure string, because they're two completely different constructs. One's a .NET object, one is a PowerShell thing. So you have to traverse those. And I needed an actual secure string, because a lot of the times the credential that I was storing was a password for a user. So I needed to be able to create a PS credential, and I needed a secure string with this. So when I ran this, script analyzer bombed a whole bunch of times. I found everybody having this same problem, and this was one of the more, I don't want to say accepted, but one of the better solutions, at least I saw, than doing just plain text. Secure, the scripto stream, new secure string as plain text, bad. So anyways, this crypto does all of those. This get non-zero bytes, this is again to replicate, I had to replicate a .NET function that didn't exist for when I did testing. And so I needed something in PowerShell to functionally do something else that .NET did that I couldn't access. So I created this. That's just a helper function for only testing. You don't need it anywhere else, but I had to put it somewhere. So if I come out here, and I'm purposely not showing you some of the other things, and I do the same thing, and I run a build, we're going to see very much the same type of thing, except now I have tests, and we'll get into that. But notice it's really not much different. Oh, let me scroll all the way up. Except now I have a few more modules. I have Pester that I'm using for testing. I still have Saki build helpers. I'm using PS Script Analyzer, and I'm loading it, but I'm not really using it in this case, the PS Deploy, which is a way to deploy scripts from your local machine out to other servers. The rest of this is exactly the same as the other one, this stuff that you really can't see, so I'll highlight it. Except because I'm doing this zip, I'm cleaning up the zip folder, because in my world, I was creating a zip folder of the module because I was uploading it to GitHub, but I'm not doing that in this example. So it still existed. I figured, why not? I'll leave it. Just to show in a different task that you can do. And I'll show you all these tasks. And here's all the stuff. Notice these are the exported. My Get AES Crypto Manager function that's private is not in this list. It is not exported. So if you import my module, you'll never see that function. It's there. It can be utilized by those, but you can't actually call Get AES Crypto Manager. And then down here, which we'll show you, it runs through tests using Pester. Again, this could be a whole talk, so I won't go in depth about testing, but realize I do a couple of things that are really out of the box. The only thing that I do that's very specific is this last test. I actually test my cryptology. I generate a fake passphrase, salt, and Ivy hash, and then I encrypt the word password, and I expect to get the word password back when I encrypt and decrypt it. It's all this test does. So that's what the tests do. The other ones are testing that the manifest is correct. The other one tests that I can load the module and that everything exists. It proves that these two things are on the scope as commands. And then this is my custom. Mike?
I have a question about your test.
Uh-huh.
Do you test that it's actually encrypted in the middle?
Inherently,
what if it just returns
inherently, yes, but not. I have to use the encrypted version to test that I can encrypt back.
Well, I mean, do you so you're testing that you can decrypt it? But
well, I take a word that's plain password, encrypt it, use that encrypted version to then decrypt and get back to my original.
Right. I'm saying, like, what if it's just passing plain text around the whole time? How do you know?
How do I know?
Yeah. You verify that the output of the encrypt is not password?
I do not.
Having done a test on a similar thing before, I recommend you do.
I will. I might add that test, and maybe we can have a building tests as our 105, and we can modify this as we keep going. That would be kind of funny. You're like, oops. And notice now my little report at the bottom shows now all of these tasks that I've asked it to run, which is build, analyze, test, zip, total. It gives me all of that. So those are the 4 items: build, analyze, test, WinZip. Those are the 4 tasks that I said by default, because I didn't give it a task list on build, to go do. So that's my default. It does all of that with Saki. Now I could tell it, I just want you to test, and test has a dependency on analyze, which has a dependency on build, so the dependencies are bottom up for the most part in this case, and it would just go up to that step. It wouldn't actually do a WinZip or something like that. So that's the basics of Saki going into a much more complex build. And why would you want to do this? Well, as Mike said, you actually probably want to test that your encryption module encrypts things, as I have not done. So, yeah. But this is what would be a much more complex version of what we looked at from Simple. Is we're actually building a module, we're testing the module, we're running it through Script Analyzer so we know if there's issues like, hey, you're taking a password and putting it into plain text. It catches those things. Does our tests, actually compiles it, and then in this case I did one extra step, which was WinZip. I zipped to the file. And not really WinZip, I just used the standard libraries. I just call it WinZip. So let's take a look at that real quick here. So I'm not going to go into tests too much. Build here is not much different. Again, the only thing that we're looking at is, hey, here's some modules imported. Same type of thing, we just have a lot more up at the top. So that code is the same. And then this is pretty much the exact same thing. The only thing I've done differently is I've allowed at the top of this to take a task list variable, which is all it's doing at the end of this line is instead of providing the default, which is WinZip, which is the very last possible task I have in my item, it allows me to specify which one I want. That's the only difference between this and Simple as far as my build goes. They'll do the build helpers, clear them out, all that good stuff. If we take a look at Saki, Saki's a little more. All right, so this has a few more variables. Some of these are used, some of these aren't, but because we're using tests, I need a test folder. We're not using specs yet. That's a whole nother thing that I haven't even figured out myself. That, again, I copied some of this from Mike and I forgot to remove it. I just haven't gotten to use specs yet. What are spec tests? Yeah, Mike. Use the mic, Mike.
Spec tests are more like using BDD. So in this case, it's the style of tests where you would use Gherkin. So Gherkin style tests instead of Pester, which is organized, described context, init blocks. Gherkin organizes kind of closer to like plain text. So like,
is it more like business fun? Like,
yeah,
it's more as of this, I want this to do this,
right,
and therefore it produces this,
right,
type of logic. Like when you type it, it's as somebody would give you a use case, right? A project manager say, hey, as a user of my system, I want to be able to log in. That's more the Gherkin style than.
Yeah, so Gherkin literally organizes your tests as given some sort of precondition, when some sort of action is taken, then some sort of output is discovered, right? So a good example would be like, given a new user has joined the organization, when I run the user onboarding script, then the new user is created into Active Directory with this condition and that condition, and this is true and that is true and this blah 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 blah. So essentially, what you do when you're doing Gherkin style testing is you specify what you want like the behavior to be, rather than like testing the individual units inside. And if you try to confuse those things, like I did for a really long time, you will screw it up and hurt yourself.
Yep.
And you'll spend hours and hours bleeding all over a keyboard trying to figure out why nothing works and everything hates you. So
Yeah.
Don't be like me.
So yes, tests are another level of testing where tests are going to be like, hey, I have an add function, and if I pass it 1 + 1 or 1 and 1, I should get 2, right? I assert that 1 and 1 returns 2. That's more of a unit test. I'm functionally testing a unit of my module. A couple of these other things, again, zip folder, because I'm producing a zip, I had to give it a zip folder. I just set those things up so I can use them. API key is left over from when I was doing other things, and so was commit ID. So tasks. So this is not much different. Build is almost exactly the identical thing as the last one. The only difference here is we had to get all the functions that were public and all the functions that were private from those 2 different directories. And then we amend them into the file. Other than that, this looks very familiar. Copy paste code of somebody else that's just testing everything and outputting things. The last thing then is now we have different steps. So now it is not ask, it is task. So this is now a new task. When we did the simple one, we had a build task. So now in Pester, I want to be able to find an additional task. So here's the syntax for a very basic task. It is task, the name of the task. If it depends on a previous task or on another task, you put your depends. That can be a comma separated list of items. You do not have to, like if in this very much case, testing depends on analyze, analyze depends on build. Therefore, test depends on analyze and build. You don't necessarily have to put build here because you can't run analyze without build. You can for completeness, it won't hurt anything. It's not gonna run build twice, it's smart. But yeah, I don't know if one way is more safe than the other because if eventually like, oh, analyze doesn't depend on build and no. Really dependencies are quite simplistic here in Saki. Once you open it up, the script block, right? Curly bracket, it's PowerShell. That's all it is inside the task. And it's just raw. There's nothing special about it. The only thing that happens is if you want to fail, you write error. And that will stop Saki. Is that if you write error out, it'll stop Saki from continuing the build process in any one of your tasks. So if script analyzer, I somehow did something wrong, it would stop at that point. So the next one I have, so that's just invoking script analyzer on my module. And that's that's just how you use the script at PS script analyzer, the module itself. It's a documented one-liner. Analyze, or test, again, this is using my test path here, and new item, test output folder, directory force. So we're basically creating the output folder inside of this, and then removing the last old 5s because I don't want my folder to be hugely unmanaged. So I'm only keeping the last 5 tests around. That's just something I added because I got really annoying to go delete 15 billion tests every time I ran a build. And then here's the actual invoke pester. So this is, again, we could talk a whole module, a whole session about pester testing. Well, Mike will, because I'm not going to do that one. And basically, this is how you invoke pester. And again, if it fails, we can exit the fail count. Basically, that will happen. And then down below, super simple, WinZip, really, really simple. We just create the file name, compress it, and go. So that's it. That's really all these are. If we wanted to create a new task, we can just, again, this syntax here, task, the name of the task you want it to call depends on something else, curly brackets, shove PowerShell in it. Give me any PowerShell, it doesn't matter what it is. One thing that's not included here that I did internally, took me forever, was I actually, when I do a build, I can actually say release as a step. And I actually took the compiled asset that I had and I stubbed in draft mode an actual release of the code in GitHub itself and attached the source files and the zip to that release. So you can go that far. If you're like, hey, everything's great, build, part of CI/CD. If everything checks out and all this is 100%, go ahead and push up a release. So you can go that far. Again, it's all PowerShell. If you want, there's a module called PS deploy. If it passes all of this and you say, yep, everything looks great, I did my tests, I did everything, okay, build, deploy. And now what will happen is you can use PS deploy to go take your scripts and push them out to server if you need to into the module directory. So there's all kinds of things you can do. This is just a workflow engine. Saki is just a way to say, hey, look, I need to be able to do these things. I need to be able to, test that I don't have bad code, right, with the script analyzer. I want to test my own stuff. I want to make sure I didn't do something stupid, like when I say encrypt, that it leaves me with plain text still. And then when I'm done, I can do something else. In this case, my something else was pushed to GitHub. In somebody else's case, it may be, well, it's done, it's sitting in directory. So let's take a look at this. So when I built this, it went and put everything that I needed in my bin directory. So let's take a look at what the output of this looks like. So in the bin directory is my module, magdev crypto. Inside that is the version 1.0.0 or .1.0.1. In there is my module, magdev crypto, PSD, PSM. Now I could say import module this whole long blah, 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 path, or we're going to use Windows Explorer because screw this. Sorry. And I'm going to go to my presentations, examples, crypto, bin, nope, not that folder. Why? And I'm just going to go to, shush. Most Windows guys are point-click admins, not Linux. Guy who uses Mac. Not anymore. You finally got your darn laptop. Yeah, finally. So if I go to my documents, right, Windows PowerShell modules, notice there's the math module sitting here. I did not write this. Somebody else did. Oh, look, 1.0. This structure seems oddly familiar. So if I come here and I place my magdev crypto here, and I open up a new window, not console emulator, import, it proved that I could load that out of my module path without saying import module right to the PSM directory. So if I did a deploy, PS deploy, and I said, hey, I need to go distribute this new version out to my servers, it could systematically put that into the directory if needed, something of that nature, and that could be loaded as import module, your new module. People don't have to find it, it is there, just like Active Directory was. So, good question.
Doesn't that require a specific version of PowerShell though?
No. As 2? 3. At least 3.
Yeah.
I know you can do it in 3 because we do it on our.
Because I know just from
2 might
past
not.
experience with like Windows Server 2008 R2 that by default includes PowerShell 2, that writing modules like this and then trying to import them before you upgrade PowerShell does not work.
So potentially, yes, PowerShell 2 might be but it's end of life, so I don't care. It's end of life. Move on. I think I've hidden the mic. Anyway, git command convert to in. Oh, look, I have not loaded it, so it is there. So again, specifying that in my PSD file, my manifest, exposes it on the commands. I could type that. I'm not going to because I don't have all the parameters. But it would load that my module instantaneously, just like Active Directory loaded. Huh? Yes, it will.
Do you want to know a secret super trick for this, Ken?
Yeah.
So here's a secret super trick. If you add your development top level folder as a folder in your PS module path,
Yep.
and then have your build into the version folder, inside of that, it'll automatically see it and load it.
So he's saying if I take, so mine is buried, I get this. My development folder is here, nope. Sorry, presentations, 104, examples. So if this was my root, right? This is the repo I'm using. If in my build, potentially, I added to the PS module root environment.
No.
Right?
I mean, so go up one level. So if this was was added statically to your
yes
PS module path,
okay,
and then inside of there, so if you go into crypto, pretend that you actually named it the name of the module, which is what most of the time you will do, right? So when you ran the build, if you built into a folder named 1.0.0 here,
right,
and had it inside of there, it would automatically pick it up. So a couple of us have adopted this workflow because it means that like I automatically add it to my module path, and then when I destroy it, it leaves my module path, and I don't have to edit anything.
This folder that I have here in my bin out in my output, which is my module compiled folder,
right?
If I instead put that without the bin here, it would potentially pick. Well, no, the version folder.
You build straight to the version folder, because then you could have 7 or 8 or 12 versions of it built locally and see what it looks like against each other.
That makes sense.
Yep. And all you have to do to wipe it out too is do a git reset hard, and it'll go back to not being there at all.
Right.
So.
Yeah. That'd be fun. You could also then just add this directory, couldn't you, during build?
The reason that you would just add the overall dev folder is that way you only have to add it once to your PS module path, sure. And then if you're reusing these builds or whatever across modules.
Yeah, I'm just thinking like if you had this and somebody grabbed it out of GitHub, my only thing would be then it won't work for them, whereas it would work for me because I knew to do that. But if I put that logic,
yeah, you don't. Well, so for them though, like in the case of where you're not doing it, where you're doing it this way, they still have to go find the folder and import it. So
and copy it. I'm saying what you said to put it in the module root, I'd put some logic here to somehow add that path to this, because on my box it's D because I have a second drive. On another developer's box, they don't have a D drive, so it's on C. That would be me. I just put it here so I never have to worry about it again, and it's in Git and checked in.
That's more of a personal development workflow thing.
Yeah, no, that makes sense. I completely get that. So the other thing, just to show you too, that's sitting here in this directory, which I'll just do here in Studio because you can see it in code, is in the zip. I actually have my magdev crypto.1.0.1.zip. So correct me if I'm wrong, isn't that the way that the naming convention of the files go? for gallery as well, but they're NuGets. Yeah, new pack. Yeah. So the only reason is I just followed the same naming convention that new packs do. When I zipped it, we don't have people that understand new packs, so I didn't pack it. So it's the same exact thing for the most part. They are. They just have a definition. They have a manifest of their own, and I mean, and we have chocolatey, so it really doesn't make sense. Anyway, you want to open it anyway? Sure. Hey, yay. Anyway, thanks, code. Thanks. So to give you an idea too, these tests are just XML outputs of what actually happened. I know you can't really see that because I'm over here, but they're just XML outputs of what the test ran and whether it was successful or not. That's really all the outputs are here. Other than that, that's the tests sneak peek. I mean, again, this is pester tests. So just to give you an idea, this is how certain things are. It's not much different than kind of how Saki is, where there's a little bit of a definition before you go do something, and then the rest of it is just PowerShell in the guts. So a lot of that stuff, when you look at it, like, oh my gosh, this is overwhelming, I'll never understand. A lot of it's just, look, there's a little bit of boilerplate around it, but the rest of it is still all just PowerShell. So even this, like, okay, fine, I named it, prove that this exists. That's just me typing that out. And same thing here. That's all this me just typing out. This could be A and A. Not real descriptive for me to know what the hell's going on. But then this is the guts, right? So again, it's just a little bit of learning what the boilerplate is around what you actually need to do. Usually by looking at somebody else's examples is kind of how I learn the most. This doesn't do a lot. So if you want to start looking at what tests look like, this does some very, very basic tests. These top things, before I get to this, validate credentials, from here up is something I include in every test suite that I have. And all it does is I first import my module, force it so that if it is already loaded and I do a new version, it reloads it. Test that, in fact, it is there, should be true. And then here, I get the module name, confirms it's loaded. Yep. And then basically test get command. I'm just doing the same things I showed you guys, right? Get command, I prove they're on the command stack. Get module, I prove that it's loaded. I'm just testing that over and over again. That way, if I put a function out there and it doesn't import correctly and it makes the whole module bomb, I know my test will fail. That's why I write those tests, to make sure that what functions I expect to be there are actually there in the scope after I've loaded my module. The rest of it is just other stuff. Me testing the creds. So that's really it, guys. That's what I've got as examples. This slide deck is out on Google. I can link it in the meetup for this one if it makes it easier to find. GitHub.com Ken Maglio presentations is where all this stuff is. There's links both ways. I think if you find it on GitHub, I think in my README, this is the Google Doc. See the slides. So either way, if you remember something, that's about it. Any questions? I'll go over to the webcast and look at questions over here. And I'll also try to pull up my weird other thing. So if there's anybody remote who has questions, you can type. Everybody will see your questions, so make it, no, I'm kidding. If there's any questions, let me know. So different thing than Plaster. So Plaster is So as funny as this may be, I would use Plaster to set up a build, a structure that includes a lot of this. So Plaster is a way to scaffold the starting point of developing something. So it's a scaffolder, right? So you say, hey, look, every time I need a README, every time I need a get ignore, every time I need a build, a Saki, a source directory that has functions folder, and that's about it. I would use Plaster to build that. And then basically, then Saki would take over once I put my functions in it, building the actual. So yeah, Plaster is definitely a good scaffolder for that. Saki is going to be the equivalent of make, bake, rake, all these other building tools that people use. A lot of the same thing is done with like JavaScript. And I know a lot of us are like, hey, we're PowerShell admins, stop talking about web dev. But a lot of this is blurring the lines. It's a lot of the same tools. We have, for a lot of JavaScript buildings, there's, I think a lot of tool of choice is Yeoman, one of the two, for doing scaffoldings. There's Bower, I know, for doing other types of building, as far as like Saki goes. Dave, help me out here. I know Grunt. Yep. And then PM is another one for Node, right? So there's a lot of different things like that. Oh, yeah. I'll just.
Slowly getting worse.
Yeah, sure, if you want to. I mean, all you need to be able to do for Maven is launch PowerShell, and you're done. I mean, that's why my build exists, because if I wanted to, I was going to be calling this, the whole purpose of me learning this and getting it working was the idea that I was going to do it through CI/CD. Now, obviously we have Jenkins, so I was going to use Jenkins. And I was going to run it actually on a Linux system, because I was going to use Core, because everything I have is Core. It works in Core. There's no reason to use Windows PowerShell for this so far that I found. You can do everything in Core. I believe every single thing I've used thus far is Core capable. So Saki, Pester, build helpers, PS script analyzer, PS deploy. When zipping stuff is, there's no module you need. It's just part of the language. All of that is, you can run in Core. So you can run all of this on Linux. You don't have to run it in Windows. So yeah, even better if it runs on Core. Yes. You?
I don't have anything.
Oh. So to get started, you could really, yeah. So to get started, if you wanted to, you could very easily take this sample, take this as your starting directory of stuff to do, and just in source functions, put your own functions, right? Obviously, here you would want to call this whatever module name. The simple folder you would want to change. Right, exactly. So that's where you would start renaming things. Now, my crypto one, in all honesty, this should be named MagDev Crypto, to be honest, because that's the name of my module here. But technically, the examples directories, these two are really representative of repos in GitHub, right? So if you were going to do your own module, it should be its own repo, right? So to give you an idea, these are individual modules, and that's super small. Snap Control, Snap Remote, Snap Core. That's a repo template that I have. So remember, the person was asking about Plaster. Plaster is a scaffolder. So instead of me having this here, that's a template that I use to set up a directory, I could use Plaster to build this for me anytime I want, rather than sticking it out there. Snap Crypto. Hey, look, where did I get my idea from pulling crypto in? All of these are individual modules, right? So each of these, if we look at Snap Crypto, you will see something strikingly familiar. of what my crypto was. I just took it because there was no real proprietary information. I don't care about sharing it. This is pretty much the exact same what we just went through. And this is a single repo. So that's why I want you to look at, like, when you look at those two directories, these should really be repositories in GitHub or something, or separate folders, right? So, but yes, simple is a great place to start. And it's the basic. It's just going to build. There's no tests. There's no script analyzer. It does use the build helpers, but there's very little that you have to do. The only thing I think that's in this simple one, oops, that I have hard coded is this right here, my output folder, bin. You could call it output, you could call it whatever, it'll create it. It's up to you. So that's the only line you might want to tweak if you don't like underscore bin. It's just stuck in my head from too many damn years of .NET development and Visual Studio compile. Yeah, Dave. Yes, I generated a zip. Okay. So let me see if I have one sitting right here. Nope, over here. So what I was going to do is, so here's this, GitHub did this by itself, okay? The source code and the source code tar GZ. This is the guts, but when I was going to consume this, the way I was going to programmatically use this is I was going to have what's very akin to like a Puppet file. I know. And basically say, hey, first thing I'm going to do is download this control. I have a snap control. When it downloads, when it initially fires, I have a config that says, hey, go get version 1 of Snap Crypto, version 1 of this, version 1 of this. So it's actually going to go hit GitHub and pull this release zip file. And I look for this particular thing. It actually does work. I have it working. But that is a zip of this guts because I didn't want to use Artifactory. I know that sounds really weird to store my asset, but so I did it through the API. So I actually have PowerShell, and in this code, there's a task in in Saki, there's a task that'll actually go out to GitHub, stage in draft a release of the current code base, attach as attachments to that this, and this. These are automatically generated based upon the commit revision, right? And I actually generate this, and then I come into GitHub and say, yep, that's good, and it publishes it. So I have that I could publish if you're interested in that, but it's just talking to the GitHub API. You just need a access token. That's why that API token was left over from the crypto that I published for this, because I use that for this. It's a lot of code and ugly, but it works for me and how we're going to do this. And then Ansible came in, and Snap's pretty much dead. Huh? Yeah, well, it will be, because everybody's super excited about Ansible, and it's getting a lot of traction, only because it's stupid simple to understand, and it's not just it's a level abstracted from code. So people who aren't scripters aren't overwhelmed by it, and it's very easy to keep things simple as you need it, and then able to go super advanced if you need to. So ServiceNow, yeah, they worked out the workflow. Yeah. They're calling, so we have Tower. So we have ServiceNow calling Tower API. Tower API has all of this stuff published, and they figured out how to do CI/CD deployment through Jenkins of an Ansible project. So you never have to touch Tower. You basically deploy it, align creds, and you're done.
Are you using ServiceNow as your dynamic inventory as well?
No. Well, we can. But unfortunately, our ServiceNow right now is not 100%. Nothing we have is. That's why we're looking at Puppet Discovery. Yeah, nothing right now is. We don't have a single source of truth of every single system that's out there, even VMs. Still not 100%. Still isn't grabbing everything. I don't think it reaches into the DMZ, which is one of the problems. So, because it only hits internal networks. Whereas Puppet Discovery talks to vCenter directly, so it doesn't care where the server is. It just queries it. Although we're having cross-forest issues with Windows, of course. So, yeah, this is something else I did here, and then this was a README. The release notes are actually a README inside my source. So that's a whole nother level of just how far you can take it. So like, see, this was what you saw as the release notes for that version is this release note README. I use that to publish it. I don't have any classes, but you know, if I do this stuff, I mean, it's no real different. Whoops. I mean, this is exactly the same thing I was just showing you guys, that I have this whole thing of doing everything else, and it's the same stuff. Once you learn how, I really copy pasted a lot of what I was doing to get the builds to work. And the nice thing is I don't have to screw with this. All I have to do is go create a new folder or a new file, call it my new function, put it in there, and hit this button or hit build and go, yep, it works. Okay, I'm good. It's once you have it set up, it's really a peace of mind over traditional types of things, because it's testing the module, it's testing that these things export, it's running PS script analyzer, it's doing all of these things that that I expect it to do for me, even if I just add additional modules. So oh, the Git? Yeah. Yep. Have you updated the release notes? Yes. This is for you, Dave, just so you can see it. So it looks at my commit history, commit on my local machine to see about the last commit and say, are you sure this is the one you want to actually push as the release, this last commit? I'm like, yes. So now it just, whoops, literally go to GitHub. And now this is sitting here as a draft, ready for me to actually hit go if I edit it. Huh? Why do you think I put it in draft? No. So this is a draft, won't be seen. Duplicate tag name, it won't let me. I can draft duplicates, I can't actually commit them. So I'd have to like, huh? So I delete this, I discard this, increment my build. It's just a double check for me in my head to say, if I didn't increment my build number, my version number of my manifest, and I did this, putting it in draft and having to hit OK here is one last final check that I didn't F up, right? So that was why I did this. But yeah, I got that working. I was like, hey, that's kind of cool. And then I'm like, and it won't ever get used. Yay. The GitHub? Yeah. It's just your own personal user. Yeah, this is just, I just go to my profile or settings. Sorry, settings. It's just this personal access token. It's just this token that I have access to. That's all it is. It's that or username password. I just chose to use token because that seemed, yeah, I didn't really want to have creds. Plus that way I didn't have to store it. I just accept it as a, so the other thing that I do, because I do this in my, if you notice, whenever a new window starts up in my profile, see the keys I load? Shush. No, no. They're only in my local scope. Yeah. For me, for my user, yes. Use that personalized. Yeah, that's our CI admin, right? Yeah, yeah, yes. Actually, I think that's exactly the API token. I do this for testing, but I think in general that I would change that and pass that as a Jenkins variable. Exactly, and that's exactly what I do with Chocolatey, right? To publish to Artifactory, is I have something that just uses my environment key to push to Artifactory. So, are there any questions? Okay, you've asked. By the way, this weird thing that you're seeing down here, that master thing, that is that's PoshGit. So it's interpreting that I'm in a Git directory, and it's telling me locally how I relate to my upstream source. So if you use Git a lot, it's just a command line tool to, or a prompt editor. That's all PoshGit does to tell you if you're ahead, behind, if you have commits, if you're behind. So if you go to that directory here, it actually shows you those things. So that's what PoshGit does. Right now, SnapCore is equal to master. So that's where that is. I'm neither ahead nor behind, I'm equal. So it does that check every time. As does Visual Studio Code down here, but you know, what else? So that's it, guys. Let's see. Let me make sure there's no more questions. Oh my God, this is going to be painful. Let me close this down. Let me close. I'm sorry for the inception. No more questions there. All right, I think we're good. I'm going to go ahead and stop the webcast. Thank you, guys. Oh, yeah. Hold on. We do have Francisco here, so. Shush. I know. Just shush. Okay. Let me know. If not, we'll purchase it and we'll just only give that PDF to that person. You want a copy, Mike? Cool. All right. Okay. First name. Why? Yes? And okay. Get random. And what? There's only 6 of us? Yeah, I just want to see if does this work? Yeah, so it actually does work like that. All right, Chris. See, you can only win if you show up. All right. Well, all right. Thank you so much, guys. I'm going to go ahead and shut down the webcast and appreciate it. If what's the URL of the book so I can show people this real quick? Puppet Conf? Is it Puppet Conf? No. Dang. That's cool. This guy. So, leanpub.com, PowerShell.conference.book. This is the site. Really good book. It's getting close to getting done. So, yeah. And just think, somebody will get to go to the PowerShell Summit. Well, multiple people, actually, right? How many have you done? Sweet. Awesome. Nice. Very cool. All right, guys. Thank you very much. Appreciate it. I'm going to end the webcast. Francisco, Chris won the book, who's here. So, yes, you did have a chance, Francisco. So, all right, before this thing gets into Inception. Yeah, no, if you just because you were here on our event, on the webcast, you're good. You were enrolled in trying to get the book. So, all right. Have a good evening, guys. I will catch you later.